Welcome again to the second edition of Depsys Café. This conversation is going to be about deployment strategies for smarter grids. My name is Ramzi Solomon, and I'm a technical account manager at Depsys, and I support customers to make effective smart grid choices. Over to you, Christina.
So my name is Christina Tzanetopoulou. I am also a technical account manager at Depsys, and I have the focus of my activities is mostly on the German-speaking part of Europe. We're looking forward to this Depsys Café, and we hope that we have a nice interactive discussion.
Right. So even though we serve different markets, mine being Northern Europe, so that's everywhere from Ireland all the way through to the Nordics. There are some consistent elements that we see across our customers, and in that light, it would be good to have a conversation with you about what you see. I'd firstly like to recognize that a lot of work has already been done by countries and by DSOs. Many countries and DSOs have defined a clear path towards CO2 emissions reductions by creating policy documents and having emissions targets. Also, there exist very strong smart grid roadmaps. However, there is a need to identifying a deployment strategy. So that's to take what is on paper out into the field. I'd also like to recognize that many DSOs have experience with various technologies, and they are, of course, those technologies have been deployed based on their grid types, and there is no single fit, of course. And lastly, I'd like to encourage our audience to participate by asking questions, and we will attempt to answer them through the session or at the end of the session. And we will also attempt to open up for any questions that you may have verbally. So let's get started. Christina, I'm very curious to know from you, what are the kinds of deployment strategies that your customers typically use, and what are your thoughts about these strategies? Of course, it is in the framework of using GridEye being a technology that is combined of three main parts, that being hardware, a management system that does all the tooling and data configuration and structuring, and then also some of the analytics that you see from the grid.
Thank you for this a very interesting question, Ramzi. So we see that there are three different types of deployment strategies that our customers are using. So the first deployment strategy is to digitalize the substation, the substations. So it is monitoring the substations. It is a fixed installation. It is about grid digitalization, and very frequently digitalizing the substations means rolling out, so digitalizing also the low voltage grid. So this is the first strategy, which involves like fixed installation and grid digitalization. So the second strategy that we see is a more targeted approach. So there, our customers are trying to focus more closely to a very specific thing that they would like to monitor. So the installation, so the deployment there is a smaller scale of deployment, and it focuses on very specific grid points, if you want. The third installation, the third deployment that we see is a more nomad approach, is how we call it. So in this case, we are monitoring specific grid points because we see that there is something that we would like to check. And afterwards, once we know what is the impact of a certain load, let's say on the grid, then we shift the device to another point. So we have this rolling approach, let's say, if you want. This would be the three.
So in summary, three distinct options that are available to customers, but I would imagine that it would be based very clearly on their needs and use cases. And I wondered whether for what you define as fixed or static, as pain point oriented and also as nomadic or changing, how they would develop the strategies then based on their needs.
Yes, exactly. So deployment is not is always aligned. So where we deploy is always aligned to what are the use cases. So what is it exactly that we are trying to achieve with this deployment? So the first strategy, which is the fixed installation at the substations or afterwards towards the low voltage grid, is a strategic approach. So this is something that we see that customers are doing when they have decided internally that they would like to digitalize the grid, they would like to gain as much visibility as possible.
Okay.
So they are rolling out to their whole grid or to all substations, and they gain some visibility into the grid. So specifically, if one is rolling out grid eye, this specific smart technology, by installing on the digital substations, one can use it not only to monitor the loading of the transformer and the loading of the low voltage feeders, but also to monitor the profile, the voltage profile on the medium voltage side. And we see that this is very important for customers who have a high penetration of distributed energy resources on the low voltage grid, and they suspect or they expect that they will have a reverse power flow on the medium voltage line. So they are using grid eyes on the substations to monitor the profile on the voltage profile on the medium voltage feeder. This is one additional feature of grid eye. Then another one is that we can use these grid eyes to do medium voltage fault management as well. So along the medium voltage feeder to localize the fault. And the third advantage that grid eye offers in terms of substation digitalization is that we can use it to have an overview of the power quality of the whole subordinate low voltage level.
Okay.
So this is an interesting point because usually we're talking about power quality in terms of end consumers. But when it comes to the substation level, if we see that there is a problem with power quality there, then we are sure that we will have to proactively look for power quality distributed sources inside the low voltage grid. So this is the use of monitoring power quality on such a higher level than the end
Okay.
consumer.
That's quite interesting because, of course, it would be good if any deployment strategy is linked to predefined use cases, and use case definition obviously takes a lot of internal work. And so, I mean, the use cases that you mentioned are, of course, important and quite diverse, right? Power quality, asset loading, asset management, fault management, particularly. They have different technological needs, right? So that's, I think, the one thing, the important thing is that there must be a very clear definition in order to begin the journey to deployment. The second thing that I see, at least from my side, is that oftentimes there is a misinterpretation that you can take what has happened already technologically in the HV and in the MV and apply it immediately in a very blanket fashion down to the low voltage grid. And of course, the dynamics are very different. And secondly, the number of points and therefore the hierarchy that exists within the low voltage grid is of course very different. And so having a focus on the low voltage grid and then defining the use cases based on your needs before a deployment strategy, of course, is very, very valuable. Um, with that in mind, I'd like to know potentially, how do your customers then define use cases? What work do they, or what stages do they go through, or what types of kind of use case profiles do they end up with?
So what we see is that there are two approaches that can be followed. So the first approach is that there are some, so before we talk about the approaches, one very basic thing is that all the distribution system operators are trying to test the different technologies and see what are the potentials, what are the limitations, and play a little bit to getting some lessons learned in order to prepare themselves for the deployment of their needs. So after this is done, Then there is a period where one needs to decide which way to go. And there are two ways that we see it. The first one is that firstly, they try to roll out to as many places as possible. So they try to gather as many data as possible from as many points as possible. And afterwards, on the second step, they are trying to see what can they do with this data.
Okay.
And this is an approach that we see a lot, and it is reasonable. However, there is a little bit of a risk there involved, and the risk is that if the use cases are defined at the end, then maybe we are not able to satisfy them all. And what does that mean? So digitalizing the grid is actually just a mean. The goal that we are trying to reach is to satisfy certain use cases, to make the everyday life more comfortable, to integrate the tool to the working process of a distribution system operator. And if we start by gathering data, we might miss some important use cases that we want, but now it's too hard to go back and fix that again. Let me give you an example. So when it comes to power quality, we know that there's a huge penetration of the electrical vehicles in the market. So I have a customer who told me that in January 2021, he received so many connection requests for charging stations as he received the whole year of 2020. So there is an uptake that we knew that it would come and is now already started, and it's going to be exponential. And we also know that the charging stations, some of them, not all of them, but some of them are having an impact on power quality. And we also know that even in the countries where this hasn't already taken place, the liberalization for the end customers is right there, it's coming up. What does that mean? This means that the distribution system operator needs to start changing a little bit his thinking. It's going to come naturally. It's not going to be a strategic decision. It's going to be natural that the distribution system operator is more proactive in terms of power quality in the low voltage grid. Now it is more a reactive approach, which is reasonable given the framework that we're working on right now. So if we have set a measurement concept before we define the use case, then maybe the measurement infrastructure that we're using cannot fulfill the power quality demand that we have. So it is a little bit more sensitive, I would say, to firstly define the use case that we want to satisfy, to see for which departments do we want to satisfy measurements, what kind of resolution do we need from the device, what kind of accuracy do we need from the device, do we need real-time data, is it going to be used from the operations department, or do we need data once per day or once per month because it's only going to be used from the asset management department or from the grid planning department. So let's figure these things out. It would be my suggestion to figure these things out before we set up the measurement concept.
Yeah, I've also seen some countries having spent up to 10 years to go through innovation and discovery. And basically over that long period of time have just collected a lot of data and now need to learn how to process all of that data or link to that data. And so obviously some of the learning that those DSOs have now is that to proactively search for the use cases and then define the technology and the roadmap strategy is of course a lot more powerful, compressing the time to deployment.
Exactly. And if I may also compliment Ramzi, in some cases we see that for the targeted approach that we are proposing, that we see that it takes place, and the nomadic approach that also takes place. So we see that sometimes it might pay off more as an investment to figure out which points are more interesting to monitor. So I can give you an example also from our customers. There is a connection request. There's a connection request, let's say for photovoltaics, it could have been for charging station. and the distribution system operator makes a calculation with the simulation grid simulation tool, and he looks at the worst case scenario. If there's no visibility in the grid, we consider the worst case scenario, and he thinks he will have to make grid reinforcement. But what we see is that many times, if we actually measure the effective loading on these cables, the actual voltage level, then we see that maybe we don't need to reinforce at all. So this is a targeted approach, and think about this, the 50 meters of cable replacement without considering the cost of the workers to excavate and so on, it equals to one smart meter device, one smart grid device. So if you make this comparison, you see that maybe it makes more sense to try to deploy a grid eye, one or two grid eyes in this area to monitor what is the actual situation before you reinforce, because maybe you don't need to reinforce at all. And this is a use case that we see with our customers.
Okay.
And another thing that we see is, for example, the power quality that I shortly mentioned, that I already mentioned. So they would like to see, especially in countries or in places where there's a high penetration of PV, they are getting concerned about the power quality. So they use grid eyes to measure on specific points. Then they see that they evaluate the power quality at these points, and then they shift the grid eye device to other points. And this way they can use like a group of grid eyes that they rotate throughout their grid. So this is another approach. These are the benefits that we get if we firstly know what is the use case that we would like to satisfy.
Yeah. Okay, so of course, it's obviously relevant to a DSO situation, to their pain points, which are clearly defined, and also the need for a flexible solution that is integratable, of course. Yeah. So there's also a point from my side, which is that there are multiple use cases, and how relevant it is in an environment of course, any DSO environment. And I'd like to touch on one aspect here, or two aspects here, which is that DSOs need to simultaneously deal with urgency and uncertainty. So the urgency of the need to resolve certain problems that are known, and the uncertainty potentially that relates to policy, as you point out, around EV strategies, around connection requests, around loading or generation that is, of course, uncontrolled or uncontrollable. So from my perspective, having individualized pieces of technology that often have low rates of success for a diversity of grid types could be a risk for a DSO, whereas if they thought about a flexible solution where applications or modules are deployable with existing infrastructure, that gives you the kind of flexibility that you could have, while not having to have multiple strategies for different pieces of technology.
Exactly. And this is a way to ensure a sustainable measurement concept, which is a sustainable investment at the end.
Right. Just in terms of operational integration, I also thought it would be important to recognize that if you've done the reactive approach, right, which is to adopt lots of pieces of technology, store data, you would probably face a massive constraint up front. Whereas if you thought about the operational integration and the operational utilization, you could greatly benefit from the work that is done by various departments coming together to structure data, to develop an architecture, to figure out what your data flow is and how you're going to gather it effectively, and then to work on the visualization of that information and who can use it operationally and how.
Exactly. And one question which comes frequently from our customers to this point is, what can you do with the technologies that you have already installed? So there can be some monitoring devices here and there can be some power quality devices here and there, and the customers want to make use of all the technologies if possible, and not to
Right.
constrain themselves to one technology or adopt
Yes.
grid eye, for example, and then have to throw away and forget the other technologies, and also try not to switch in different platforms according to
Sure.
technologies. So I wonder, what's your view on this topic?
Okay, well, obviously there is a regulatory influence, which is that after an investment is made, that asset should be utilized. And I certainly don't think it is prudent to throw away any asset or any system, whether it be an IT or an OT system, just for the sake of clearing it out and putting or replacing it with something new. Um, Certainly, when you make a big asset investment, you want to get the best benefit out of it. So I would actually make the assessment with the DSO that I'm working with to figure out, well, what can be combined together in order to give value and not to create competition. And of course, if there is something wrong with measurement, accurate measurement, then the organization would have to reconsider, of course, the measurement that it receives into its systems. And then, of course, the second is if technology is not serving the purpose and doesn't fit and align very clearly with the use cases that have been defined, well, then you've got to figure out how to bring value to it or to phase it out and phase something else in. So certainly that work needs to be done in a combined fashion with all the stakeholders involved. And of course, it's about asset preservation too. Yeah. So
Should
thank
we
you very much for your uh, engaging and thought-provoking perspectives from your customer base. I would like to open questions up to the floor. And wanted to know whether there were any points that our attendees had about deployment strategies.
So we can take questions written, but if anybody feels like engaging verbally, you're free. We're looking forward to hear something from you.
Absolutely. I think we have some participants, but they are muted. So what I'll do is I'll begin with a bit of a summary, and then if there are any questions, anybody can just stop me or write them down, and then we will answer them. But just to summarize, I would say, based on the information that you've shared, Christina, there are 3 deployment strategies. One, of course, is what could be defined as a sort of a top-down approach, which is to connect cells at substation level. You know, the other is a more strategic and defined approach, which is to identify pain points or specific utilization for it, i.e. when investigating PV or power quality. And then the third is this nomadic approach, which is to get an overview of various parts of your grid and then use that data to support a deployment strategy that you then define. The second, of course, is the very important point that you made, that you could either do things, either develop use cases um, proactively, or you could have like what is very typical, which is to collect tons of data and then process it, which obviously takes a lot of resources and takes a lot of time. And I thought that was very valuable. And then the third, of course, is that digitalization itself is just a means and not the end goal, but the goal really is to define something relevant to you as a DSO based on your grid size, your grid type, the network configuration, and your operational and system needs. And of course, the idea is to continuously receive reliable grid data that is accurate and usable, and that is visible across your network. The other is that I would think about the operational implications of the solution. And of course, if there is only one team that benefits, or there is no kind of integrated strategy for the utilization of the historical databases and the real-time data, it of course wouldn't serve the organization very well, especially since solutions need to be sustainable and economically efficient.
I think that's a very good summary, Ramzi. Thank you very much.
Oh, it's my pleasure. So, since there are no questions, I'd like to say thank you everyone for your attendance, and we look forward to seeing you at the next session, which will take place, as I said before, the last Wednesday of every month. Thank you very much.
Thank you.